Okay, I hope you can see everything. At any rate, hello class. Tonight I am going to solve problem 6 from homework 4. And while, as I promised, there will not be a question quite as complicated as this on the final, on the midterm exam, I really hope you will pay attention because a lot of the concepts covered in this question will be on the midterm, and are also, the whole thing here is going to be important for us understanding the whole rest of the course. Some of the concepts in here come into play as we get into some of the other issues that the course addresses after the midterm. So let's start off. Suppose that there's a market as described by the following equations. So we have the quantity supplied equals 2 times P. So obviously, as the price goes up, the quantity supplied is going to go up. We like that. We want supply curves to slope up. And then the quantity demanded equals 300 minus P. So of course, it's very important that there's a minus sign in front of the P, which of course is going to say this is a demand curve that slopes down. We like that as well. So these are both very normal and very well-behaved curves. And the question then is to solve for the equilibrium quantity. Well, that's hopefully fairly simple for you to do. We're just going to set the quantity supplied equal to the quantity demanded, and we will solve for P. So we're just going to add P to both sides. So that says 3P equals 300. And then we'll divide both sides by 3, and we'll get that P equals 100. And then just to check to make sure this answer makes sense, we'll plug 100 into both equations. So if we plug P into the supply equation, we have quantity supplied equals 2 times 100, which equals 200. So that's good. Well, it's an answer. And it's good if it matches this. Well, if we put quantity demanded equals 300 minus 100 equals 200, and so we have success here. You know me, I always need more colors. We have success here that the quantity demanded equals the quantity supplied. So we have a solution that makes sense. So that's the answer to part A. Okay, so now the fun really begins. The question says, suppose that a tax of T is placed on buyers, so that the new demand equation is that the quantity demanded equals 300 minus P plus T. And I want to get rid of these parentheses right away just because it's easier for me. So we're going to say the quantity demanded equals 300 minus P minus T. And remember, the quantity supplied is 2 times P. And so we want to make sure that we're in a situation where the seller is going to get P, the buyer is going to pay P plus T, but the quantities have to be the same. So the quantity supplied at 2 times P has to equal 300 minus P minus T. And so we can now bring the P over. So we'll add P to both sides. So this is 3P equals 300 minus T. Then we divide by 3. And so we will get P equals 100 minus 1/3 T. So this is what the seller is going to receive. And the buyer, of course, is going to receive this. So this is what the seller receives. And then the buyer is going to pay P plus T, which equals, of course, 100 minus 1/3 T plus T. This is what the buyer pays. So we can this is minus a third t plus a t, so this is 100 plus 2/3 t. And this is what the buyer pays. So notice, buyer pays. So notice that the difference between what the buyer pays, which is 100 plus 2/3 t, is exactly t different from what the seller receives. So the seller is going to receive 100 minus 1/3 t, and t is of course going to go to the government. The buyer is going to pay 100 plus 2/3 t. So as we can see, this tax, a third of the tax is being borne by the seller, and 2/3 of this tax is being borne by the buyer, which of course has to do with the elasticities of the demand equation and the supply equation. Just to make sure this all makes sense, let's figure out what the quantities would be. So 2 times P, which would be of course 2 times 100 minus 1/3 T. We can probably do that in our head, but let's just write it out. Quantity supplied equals 2 times 100 minus 1/3 T, which is of course 200 minus 2/3 T. So this is the quantity supplied. And our quantity demanded, of course, is 300 minus P plus T. So the quantity demanded is going to equal 300 minus P, which is, of course, 100 minus 1/3 T. Oh, actually, you know what? Let's do... actually minus, and then we have to add the t in here. So it's 300 minus, the same expression that's here, 300 minus 100 minus 2/3 t, and so this becomes 200 minus 2/3 t, which of course is the same expression we had over here. So this is the quantity supplied, this is the quantity demanded, and they equal. So again, I'll circle them in red, that this is the quantity demanded, this is the quantity supplied. So as we can see, the quantity before was 200, it has now been reduced by 2/3 t, so the quantity has been reduced. The price that the seller pays, the price that the seller receives has gone down by 1/3 t, and the amount that the buyer has to pay has gone up by 2/3 t. So that answers part B. What happens to the price received by sellers? It goes down. The price paid by buyers goes up, and the quantity sold is reduced. Now, getting more exciting here. Tax revenue. Tax revenue is T times Q. Question tells us that. We should know that already. The quantity sold times the amount of tax is what the revenue gets. So we'll call that R for revenue. Revenue equals T times Q. And of course we know what Q is. So R is going to be T times 200 minus 2/3 T. And it tells us to graph this relationship between 0 and 300. So R equals 200 T minus 2/3 T squared. Or we can look at it. We can look at it from both, either multiplying it through or not, as obviously it's the same. So thinking about it for a second here, let's. It tells us 300, which is a nice little piece of information to have. Although you'll see, we'll be able to figure out that this 300 is an important number without actually knowing ahead of time that that's what it is. So let's start off by just looking at this part. If t is 0, of course, we know the revenue is going to be 0. And it's very simple to see this. T times this, well, 0 times anything, of course, is going to give you 0. So this is the tax rate. And this is the total revenue on this axis. And so when the tax rate is 0, we're going to have 0 revenue. That really makes sense. Now, we can think about like this part. What if this part were 0? Then also we would have 0 tax revenue. So we can just figure that out here. 200 minus 2/3 T equals 0, which means that 200 equals 2/3 T. which means 600 equals 2t, which means 300 equals t. So we realize that when t equals 300, that we're also going to have zero revenue. And you can just sort of eyeball, as you put this in here, 2/3 of 300 is 200. 200 minus 200 is going to be 0. So we know that this is going to be 0 right here. So we know it's 0 here, we know it's 0 here, and we can just sort of assume that there's some sort of curve like this. This is actually a pretty symmetrical relationship, so in fact the revenue is going to be maximized at 150. And now we're going to digress just a second here for those of you who are not afraid of the word calculus. You don't have to know calculus to take this class, but we all know that calculus exists. It's one of the great achievements of the human mind in the history of our species. And so let's use this little expression here: 200t minus 2/3 t squared. The way to find this high point in the bar is to actually take the first derivative of this and set it to 0. You're just going to have to believe me that that's how you do it. And so the first derivative of this would be 200 minus 4/3 t. And we set that to 0, and that means that 200 equals 4/3 t. That means that 600 equals 4t, and that's going to mean that t equals 150. And so right this halfway point between 0 and 300, 150, is where our tax revenue would be at a maximum. Like I said, you don't really need to know how to do that to take this course, but it's a nice, it's nice to because we just sort of eyeballed it, but it's nice when the numbers actually prove that what we were eyeballing was correct. And now I realize you can't see all of that because I wrote down too low. Same thing problem I do in class. So there you go. You can look at that, stare at that for a few minutes here, and realize that the high point of the curve is where the tax equals 150. All right. There we go. All right. Now, the deadweight loss of a tax is the area, I'm just reading from the question, deadweight loss of a tax is the area between the supply and demand curves. Recalling that the area is half the base times the height, solve for the deadweight loss as a function of t, graph this relationship for t between 0 and 300. So let's do that. So let's go back to our very beginning, where we knew that the quantity supplied equals 2 times P, and the quantity demanded equals 300 minus P. And so this is our quantity. And, actually, you know what? I need to make enough room for two graphs, so let's not get too carried away here. We're going to have our quantity and our price, and so quantity supplied equals 2 times P. So we realize when P is 0, the quantity supplied is going to be 0, and we're just going to have a line that's going to go right up with a slope of a half, because obviously the quantity is on the x-axis, and so every time we're going to have twice the quantity every time the price goes up. And then on this axis, you can realize that if the price is 0, 300 will be demanded. So this will be 300. And we could also think that when the price is 300, the quantity is going to be 0. And so we have a nice straightforward line here. This is 300, and there we go. We have our demand curve, and we have our supply curve. And now we can think about the deadweight loss. Well, the deadweight loss is going to be the area of this triangle, and it is the difference between the quantity at equilibrium and the quantity with the tax. And then this height of this is the tax. So the deadweight loss is going to be half the base, which is Q equilibrium minus QT times the height, which is just the tax. Well, we actually know what this difference is, because remember, in the earlier part of the question, we found out what the quantity was going to be after the tax. And that quantity, which I remember I was very happy that the quantity supplied equals the quantity demanded, was 200 minus 2/3 T. And we know what this quantity is, because the very first part of the question, so this is the quantity with the tax, and the very first part of the question we solved for the equilibrium quantity, which of course was 200. So we know what this distance is. It's 2/3 T. So the base is 2/3 T, and the height is T, and so the deadweight loss is 1/3, because 1/2 of 2/3 is 1/3, T squared. So this is the deadweight loss. And so we can, of course, graph this. 1/3 T squared is going to be a parabola kind of thing that we can graph between a tax rate of 0, because we know there'll be 0 deadweight loss at 0, and this would be at 300. And we can even calculate what this is going to be at 300. So 300 squared is times 300 is going to be 90000 divided by 3 would be 30000, and so we know that the deadweight loss at 300 is going to be 30,000. And at 0, of course, it would be 0, and it's going to have an upward slope like that. So I'll get the shadow out of the way and see if we can noodle on that for a few moments. I think this is a very exciting question. I hope you do too. All right, so now we're at the very end here. The government now levies a tax on the good of 200 per unit. Is this good policy? Why or why not? Can you propose a better policy? Well, of course it's a bad policy. The higher the tax rate is, the higher the deadweight loss. We know that. And as we learned earlier, I'm going to erase all of this. As we learned earlier, the maximum amount of tax revenue you can get is at 150. So if they're proposing a tax of 200, they have a higher deadweight loss, and the government is raising less money. So is there a better policy? Of course, there are many better policies. One policy would be to cut the tax rate to 100. You'll get the exact same amount of money you would get at 200, and yet the deadweight loss would be less. Clearly, right, the lower the tax, the lower the deadweight loss. Or even if you just cut it to 150, the government would actually get more money, and the deadweight loss would be lower. So either one of those policies would be better. It's easy to see that the lower the deadweight loss is, the lower the lower the taxes, the lower the deadweight loss is, because this is a positive number here. But the last thing I want to do is I will just prove to you that the revenue would be the same at 200 and at 100. So remember, the revenue is the quantity times the tax. So if the tax is 200, the quantity is going to be 200 minus 2/3 of 200. Right? Because remember, our quantity is going to be 200 minus 2/3 T. And so this is going to, you can put this in your calculator, and you're going to see this is 13,333, blah, 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 on and on. But it ends, it's basically $13,333, and then a 3 that continues. And if you look at, if the tax is 100, that would be our tax revenue. Our quantity would be 200 minus 2/3 times 100. And that also is going to equal 13,333, blah, blah, blah. And I'll let you do on your own the fact that if you did 150, you would actually end up with a higher number than 13,333. So you can prove that to yourself. I appreciate your attention to this video. I hope you have a good studying for your midterm. If you need to speak to me over the weekend or anytime on Monday, my phone number is on the syllabus, which is on Husky CT. So, call me maybe. And I will also, just to remind you, I'm sure you've seen this 100 times, but I will put my email address on the board here. And so, you can email me maybe. So call me maybe, email me maybe, email me maybe, and good luck with all your studying. Thanks for watching.